Hello, hello. Are we on? Are we on? Are we on? Uh, oh, there it is. Okay. Whew. Okay. All right. Okay. Let's see if we got this straight here. Okay. It is now 3:10 p.m. on the East Coast. Okay. This is, in a sense, take two for for today's live stream broadcast. Hello, everyone. Brian Sapinski once again here at my channel. Okay, let me explain real quick what's going on here. If you're confused with all the live stream business right at this moment, um, I went on at 2 o'clock as originally scheduled. Everything seemed to be going fine. Then about a half hour in or whatever, my my internet connection decided, nah, I'm good here, and I'm taking a break. So all of a sudden, my live stream cut off, and or it was telling us we had connection trouble. Couldn't get it back going, so I had to kill the broadcast and do whatever. So and I was right in the middle of doing some explanations of things. I had people asking me questions, which was good. So, all right, so we're going to try this again. Okay, I'm going to go from the top. I'm going to do everything as we did it so far. And I know I had at least one person checking in and was asking me some geometry-based questions, which I'm going to recreate what we did already, and we'll do some other things going forward. We'll also do what Brianna was doing with me at the beginning of the video because she had some more questions related to her Roblox stuff, or whatever. In the meantime, I will just continue to suggest if you have any math topics yourself, anything in the K through 12 spectrum that you'd like to find. Get some suggestions about or whatever, this is how you do it. Just submit a topics. There's a live chat waiting on the side here for you to put your stuff in, and yeah, and I'm just gonna leave a message in there just for a moment. Uh, Okay, so I just want to put that in there. Hopefully, people will see it. But yeah, just go into the live chat, type it in, whatever it is that you want to know about. Also, at the same time, if you're not comfortable with or is familiar with doing live chat business or whatever, and you want to submit your your topic ideas a different way, there's my email address, brian.sapinski@gmail.com. You can send it to me that way, and we'll do it that way also. Okay, so that's how it'll always be based here. And hopefully the internet will keep this time. So anyway, all right. So let me start with okay. I had a student that was here for the take one of this a little while ago that was asking some questions with regards to she had some geometry work that she was doing, and she was bouncing around within a couple of topics. So I'm going to take what she was doing. First set of stuff that she was asking questions about had to do with angle pairs, chain pairs of stuff that she was looking at. Okay, she was looking at complementary angles, and she was looking at supplementary angles. Okay, Katie, if you're watching again, I know you said you got this, and I hope this will continue to assist you with what it is that you were doing. Complementary and supplementary angles, that in these circumstances, we're talking about pairs of geometric angles. And now understand, and these angles, when you see them, they could be adjacent to one another, meaning that they could be physically connected to each other by a common ray that passes through the middle of them, like this, or they could be totally disconnected from each other in two other places in space, and that's fine too. Okay, supplementary, same thing. You could see they could be connected like this, or they could be in two completely separate places like so. Doesn't matter. What is going to matter in these circumstances is the numbers themselves that are involved in this whole process. Okay, so that's what we're going to see. The complementary angles, the way that they work is that when you take the measurements of the two angles and you add them up together, the idea is going to be that the total is that they add up to 90 degrees, which means that they have to create a right angle together with each other. Okay, so that would mean then, for instance, in this example, that would mean if one angle were to measure 70 degrees, for instance, that would mean that the other one would amount to 20. It will come out to that. Basically, the idea is just taking the 90-degree total and subtracting the angle that you know to get the other one. That's pretty much how it is. And even if they're disconnected, that works too. So for instance, okay, if you're told that one angle is 32 degrees, so, to do that one, okay, then that would mean that the other one, again, if you do 90 minus the 32, you would get, in this case, 58 degrees. So that would be the measure of the other one right there. Exactly. That's perfectly the way it works. Okay. Then you have the other type, supplementary angles. Now, this time, instead of making a right angle, which is 90 degrees, supplementary means that the two are, if when they are connected, they combine to form a straight line, a straight angle like so. And when you have supplementary angles that do form, when they are connected to a straight line, you will sometimes hear the term linear pair also used to represent them as well. So understand those terms are semi-interchangeable. You'll see that as you work your way along. Okay, so supplementary angles mean that instead of adding up to 90, we talked in an earlier broadcast about the linear pair, about a straight angle being 180 degrees. So that's what they have to add up to. So they have to add up to 180 degrees this time. So that would mean, for instance, if this one angle was 110 degrees, okay, just do 180 minus 110 and you get the other one. So in this case, it would be 70 degrees for that one. Same idea. If you were told that one angle measured, let's say, 55 degrees, I can do a better 5 than that, 55 degrees like that, okay, so then do 180 minus 55 and you get the other one. So in this case, it would come out to 125. That would be the measure of this one. Okay, so that's the way that goes. Perfect right there. Okay, so you have that pretty much in place. Now, just to take this a slight step further, just so you see what's going on with that or everything. Let's suppose that you were to see a similar type of problem to these, but let's suppose that there was a little bit of algebra involved and stuff like that. Okay, so in other words, let's say if instead of giving you straight numbers, let's say on it, if for at least one of these two angles, they gave you an algebraic expression to put together in those circumstances instead. Like, what if, okay, let's stay with the complementary situation, for example, and understand this example that I'm about to put together. It works just as well you were given if you were given a supplementary situation. The only thing that's going to change in here is when we set the equation, what number goes at the end of the problem. So let's say, just to recreate the one I had before, okay, let's say that this angle you were told measured x plus 10 degrees. Let's say that this one over here were to measure, okay, well, here, I'll change it up a little bit from how I had the question originally. Okay, 3x plus 36 degrees. So let's say you had that. Okay, so knowing that you're given that they are complementary, meaning that they have to add up to 90, that means these two expressions would have to get added together and the combined total of them has to equal 90 on the other side. So it would look like this. You have the 3x plus 36 plus the x plus 10 equals, and again, the 90 total. There it is right there, and stuff like that. Okay, so that's the nature of it there. Okay, so this would be your SEP. Now, just like any other algebraic problem, you got to consolidate and you got to simplify this side because you got 4 terms over here. Before you can do any algebraic cancellations, you got to get it down to 2 terms. We've talked about that on the previous shows as well. So we take the 3x and the x, we combine those. Okay, so we get 4x out of that. Total of those, because remember, there's that silent 1. In order for you to see that x, there always has to be at least 1. We take the plus 36 and the plus 10, we put them together. So 2 positives, we add those together, we get a 46 out of that. And so now we're down to this. Now you officially have a 2-step algebraic problem. And from here, you can now do your cancellation. So we get rid of then as we clean up how our x looks here. I make a mess. What do you want? So, okay, we then divide by the 4 on both sides. Okay, so we get that. So you end up with x equals 11. Now, if x is all they want you to find, then great, you're done. Usually, they'll probably want you to go further in the sense that they want you to then proceed to take this 11 and plug it into both of the angles so that you can see exactly what measurements they are. So for instance, in this case, okay, if I put that 11 right here, so we get it. So 11 plus 10 means this angle measures 21 degrees. And then at that point, you have a choice. If you want to if you want to take this 11 and plug it into the 3x here, calculate that and get the measurement, you can. Or your other option is, since you already know what this one is, you could do, in this case, that would give you 69 degrees for the other measurement, which that justifies because 3 times the 11 would give you 33, and 33 plus 36, that is 69 degrees there. And 33 plus 36, that is 69 degrees there as well. And between those two, they add to 90 degrees, and you're all set to go. So everything is, you know, back in satisfactory and all that fun stuff. So we got that right there. Okay, so that's one geometric topic. Okay, I'm getting a couple of other suggestions here and stuff like that as we go forward here. Yes, I have those questions. I am getting to them. I'm getting a couple of area and volume submissions from some friends of Brianna that are chiming in from parent to parent, from Andrea to other people here. And okay, but before I get to that, I want to get to the topic I was in the middle of before the internet decided to take a powder on me or whatever. And here I'm gonna get Brianna up here, uh, back up here for a second because I'm gonna need her for the discussion because I know you guys have liked seeing her and stuff like that. Might as well get her back in for what we were talking about. Or whatever. I told her to just take a break for a second before she came back because I wanted to just get through this topic very quickly, just to refresh it here. Okay, I had a student a few minutes ago that was asking me to do some questions about area of a circle. I want to visit that area of a circle topic, and I also want to get circumference along the way as we were in the middle of this discussion. Yes. Okay. Why are you breathing heavy?
Why?
It's not like you had to run a mile to get here or whatever. Okay, you only had to just come up the stairs real quick. It didn't require the like as if you were doing a marathon.
I'm sorry.
Oh, you're fine. Relax. Anyway, okay, all right.
But I made the thing.
Okay, all right. I'll fix it in a little bit. Anyway,
Is this good?
okay. Sure, why not? Did you email it to me so I can?
Oh, not yet. Ah!
Yeah,
I'm about to fall off the thing.
yes, control yourself. Don't get too excited that you take down the whole set. The internet's already gotten taken down once on us here, or whatever.
Oh yeah.
Yeah, so yeah, that's enough. That's enough takedowns for us to last a while. So so let's not have any more. Anyway, okay. Let me get back to. I was in the middle of talking about circles. Let's get that circle discussion continued or whatever. Okay, so we got that. Now let's see if you remember what mommy was saying.
Huh?
Let's see if you remember what mommy was saying when she was up here trying to assist in her own way and stuff like that. She was saying that as far as the element of a circle goes, the whole idea it revolves around knowing the measurement of one key segment, and that segment is right here. It goes from the center of the circle to the edge, and it's represented by the letter R. What did mommy say it stood for?
Mm-hmm.
remember what name was?
No.
There's somewhere there. Okay, all right. It's called the radius. Okay.
Yeah, I wasn't close at all.
Okay.
I was going like,
you had.
no, this is what I was going for. I was going for.
This isn't like. This isn't like Psycho. This isn't like.
No.
Not even that. Old movie references and stuff or whatever. And when we get to that point,
No, it's
God.
because I can't do it like.
What is that? What is that? That's so hardening on the ears. Where did that come from?
Memes.
Yeah, of course, memes.
I don't know. I first heard it at school.
Another one of the things that's going to be vital to our survival, probably in the next
When
in these next few months and stuff
class,
like that. Who does that?
Huh?
Who does that?
You want a specific name?
Yes. So I know who not to have around me, so I can save my eardrums. Who does it?
She. It first came.
Here, whisper to me. Okay, fine, whatever. All right. Anyway, moving on.
And it
If this is you and you're watching, cut it out. Anyway, let's get back to the discussion.
Gigi also does it too, but not as much.
Okay. Well,
sometimes she does it, but still.
Okay. Well, getting back up. All right. There's two main calculations that I want to discuss here. Okay. The circumference. Okay, and the area. Okay. There's a formula involved with each of them. They're very similar to each other in design, but I want to make sure that we establish properly how both of them are supposed to go, so that
There's a pretty big chance
so
that
everything
she's not
is
watching,
properly in place. Okay, all right. Well, we'll save it for later. Anyway, okay. Circumference. Now, circumference represents the distance going all the way around the circle. It's kind of similar to how perimeter would go with a triangle, with a rectangle, or other sorts of things like that. The formula for the circumference of a circle involves the multiplication of three numbers. Number 2, the famous Greek letter pi, which we'll get into that in a second, and the radius. Okay, you're recreating your pie drawing again. That's fine. I think we could probably use some for dessert after this is over.
We're gonna get pie?
Today. I have no idea.
Mom, can we get some pie?
I don't know if she heard you.
Exactly.
Just here, do me a favor. Tell here while I pick this back up for a second. Tell her to go on YouTube, and so that she could pass the link along to I think Gianna needed to see something. So just go.
I could do it.
Just go tell. All right, go. All right, yeah.
I could do it right now.
Yeah, just share the channel so Gianna gets to it. Anyway, okay, so here's the way it looks. So that's the formula for the circumference. So let's just say, for example, let's suppose that the circumference of this particular
YouTube
circle.
is a liar. It still says that you're not streaming when I go to the live page.
It better be.
Liar! You have to physically go to the channel.
Okay, so go to the channel. That's fine. Okay, there it is. Oh, okay. So now we got the delay. Mute that so I don't hear an echo. All right. So in this case, then, if the circle had a measurement of 8 units, and right now it doesn't matter whether we say inches, centimeters, feet, whatever it happens to be. Let's just go with 8 straight units. Now, depending on your source material, that's going to determine exactly how you're going to have to phrase your answer and stuff like that. So let's suppose, for instance, so just to set up the formula first, okay? So you'd have 2 times pi times, and your radius of 8 would go right there. Okay, now, so if we do that multiplication, okay, so first, as we started to say before we got cut off, 2 times 8, that's going to give you how much?
8 is 16.
Okay, so we get 16 out of that.
Huh.
So at this moment, you've got 6.
What is
So at this moment, you've got
I'm taking
16
this
pi.
very literally.
Yes.
So you have 16 pies.
Now here's the thing. Okay. And I was gonna say do something else with that, but no, that's okay. No, that technically would have been wrong. Anyway, okay, moving on.
That's a lot of pies you got.
Show you now. In some, okay, wait, back off a second, because I gotta see here for a minute. You're blocking the math here. Okay, now
Yummy pie.
Okay, chill.
Oh no!
I know we need some levity because of the interruption here, but we gotta still keep doing what we're doing. Anyway, so here's the thing. Sometimes in some questions will ask you, okay, leave your answer in terms of pi, and if it wants that, then this is exactly how you leave it. You don't touch the number pi at all. You just leave it like this, and that's good to go. Now, in some cases, they actually want you to translate pi into its value and do the calculation then based off of that. Now, pi is they'll usually ask you for pi to use 3.14. Okay, they'll usually ask you to use that as abbreviation because, as some of you hopefully already know, pi is an infinite, never-ending decimal. It just it's an irrational number in that it goes on forever. It has no repeating pattern to its digits and stuff like that. So you just
Is there a pattern in the first place?
No, that's what I mean. No, there's no pattern to it at all. Okay, you could carry it on forever and ever, and it's never going to have a.
So you could literally say that pi is just a bunch of random numbers.
Well, that's part of what makes it irrational. The fact that it doesn't have a definite pattern to it, and the decimal does not stop. That means what it means for a number to be rational in the first place, Brianna, is that a rational number is created by the division of any two integers or whole numbers. Okay, as long as that's possible, then you could call it rational. But pi, it's impossible to divide two normal numbers and get that decimal in any way, shape, or form. So that's the key there. So if they ask you to use 3.14 for pi, then your calculation would now be 16 times that 3.14, which we had just calculated before we got cut off. And it would come out to 50.24 units.
That's a lot of slices of pie.
If
I'm saying this.
No, that's saying that's how far the pie is around.
But no, I'm thinking. Oh, there's 50 whole pies and 24 extra slices.
No. That's not how it goes. No.
Yes, yummy.
No.
I'm hungry. I want pie.
We'll figure out dinner after we get the show over.
We have pie. We'll have pie for dinner.
So continuing from there. Anyway, moving on. So all right. So here's the deal. Now, in some cases, they want you, instead of using the rounded number, they want you to use the real number pi with all of its irrational digits and everything like that. Usually in a case like that, then they'll want you to round the answer, likely to two decimal places to match what you were doing in the first place if you did the 3.14. Now, here's the thing. You'll see that the answer using the real pi is going to be slightly higher than what you did if you used 314, because you got to recognize that the reality of this. So, like, I know like the first 15 digits, by heart, definitely. It's 3.14159, 26535. Okay.
Coincidentally, there's actually
89793. I don't want to go beyond that. I usually, when I ask my students to try to see how far they can memorize into the digits of pi, I give them the digits in chunks of five at a time to try to make it easier to memorize here. So that's why I've got the first 15 down. I don't want to go any further than that because I don't want to make a mistake off the top of my head, because I know that the next two blocks of 5 digits start with a 2, and I don't want to accidentally put one block before the other one. I know what they both are, but I don't want to mess it up. If you happen to, if you know off the top of your head what it is, or as you're seeing, see if you can tell me without looking it up, and leave it in the comments or in the live chat or whatever the case is.
Coincidentally, I've seen there's like
a
video on TikTok, and they like show all the numbers of pi, and it's like actually like a song, like 3.159.
No. I've heard. I know. I've seen. Wait. Right. No, wait. Okay, you're thinking. Okay, you're thinking. Wait. You're thinking of the exact same video I am. Because
Oh wow.
No. Because right before, hold on. Right before we left for vacation, or I shouldn't call this vacation. Before we all got locked out, from being in school and stuff like that. Whatever. No, one of my students showed me the same video. Yeah, they took. Yeah, they took. It was.
It was like a stop motion.
No, it was. But I'm saying the music that they used for it is. We'll see if we can redo it for. We'll see if we can recreate it for one of these videos. We'll see if we can. We'll see if we can get it.
I keep hitting the computer.
Okay, no, you keep hitting the table. It shakes this away. No. But yeah, they took a classic music piece. I have to actually look up which music piece it was, and they set saying the digits of pi. No, I know exactly what you're talking about. We'll get that queued up later if we
It's
can,
like,
or something like that.
I know it's something from the
But anyway,
Nutcracker.
but
It's something from the Nutcracker.
No, that's not. No, that's not the Nutcracker. No, the Nutcracker is the.
I know I've heard it before.
For you Tetris fans out there, that you recognize that music in a heartbeat. That's Tetris uses the Nutcracker suite. All right, but that's our music corner for today, folks. Anyway, so using this rounded to 2 places, we would get a slightly higher number of about 50.27 units. That would be the case there. Now, here's the thing. When they give you the radius like this, great, fine, no problems, no worries. But there's sometimes that there's a different segment that they could give you in a circle ever. The radius goes from the center to the edge. There are some cases where instead they will give you this. Okay, they will instead give you a segment that runs like this, where it goes all the way through the circle, passing through the middle. Now, do you know what the name of that segment is called?
Looks like a Pokemon.
Hush.
It does. Pikachu, I choose.
Starts with a D. You know what it's called?
No.
Okay. All right. No, I wasn't sure if they. Have you really gotten much into circles yet? Or
no.
I guess, okay. But you're going to very soon, so just be ready for it. It's referred to as the diameter.
Oh.
Okay, you've heard that term.
I
used to know right off the top what it was. Anyway, okay. Here's the thing. Because of the fact that the diameter goes all the way through the middle of the circle, okay, here's what you notice. How many radii, that's the plural of radius, how many radii would you be able to make from a single diameter? Just look at how it looks. How many of these would you be able to make out of this? Yeah, how many radius? See, radius goes from the center to the edge. How many of the? There's 2 of them. Yeah, because you got one here and you've got one there. So the one thing you have to see is that the diameter is equal to 2 times the radius. And if you notice in the circumference formula, there's a 2 and a radius right there. They're both right here. So as a result, the 2 and the R can also be replaced by a single D, like that. So this is the same formula as that, because again of the connection between this and this. So as a result, let's suppose they gave you a diameter in this circle. Let's say they gave you a diameter of 10 units. So if you wanted to get the circumference off of this, you could just immediately multiply 10 times pi, and you're set. Now, once again, if they want it in just as in units of pi, then leave it like that. If they want you to do the actual multiplication, whether it be times 3.14 or 10 times the real number of pi, you get those measurements and you go on. If they just want 3.14, that's easy. Times 10 in this case would mean just move it over 1. You have 31.4 units. If it's 10 times the real pi, okay, move it over 1 place from here, you'd have 31.415, which would cause a round up, and you'd get about 31.42 units, give or take. Okay, so That's the story there with circumference. Okay, so that's how circumference works. Now, my student wanted to know about area, which now I'm going to discuss that formula, but I know that if you're going to, when you start talking about circles, it's important to know circumference as well as area, so we'll get into that. Now, what is area?
Still doesn't look like a circle.
What is, well, don't make it anything else just yet. Okay, but wait.
Circle.
But wait.
It must be circle. Oh no!
Jeez. Now you're making me lose pen caps here. Okay, but anyway.
Yes, circle.
All right.
Dang it!
Well, here, while I get that set up here, where's the area? Where's the area? Okay, where's the area of a circle? Where do you find the area of the circle?
In the middle.
Okay, well, specifically, like where in a figure is its area? What is the area supposed to stand for? The space inside the figure. Okay, so that's the same deal here. So area is all this. Okay.
I know I've heard the Pie song tune before. I just can't.
Okay, don't worry about it right now. We'll get it later. Okay. So that's it there. So that's where the area goes. Now, again, the radius is the big key here.
Sure? Is it from the Nutcracker?
It's not the Nutcracker. No,
it's
no,
like
no.
One of them.
We get. Again, you're thinking of the wrong song, but we'll figure it out later. Anyway, area formula. Again, it's going to revolve around the need for the radius. Okay, the formula this time for the area of the circle, it still has pi. It still has pi in it. It still has the radius, but this time instead of a ×2, this time you are squaring the measurement of the radius. Okay, that would be the same as saying if you want to expand upon it, that would mean you're doing pi times the radius times another of that radius. The square means you have to use it twice. So in our original question, if we have if the radius is given to us straight up of 8 in this case, then that would mean.
Oh gosh.
That would mean in this case
Don't
that.
You think the pi symbol should be an actual
Joe,
pi?
Stop. It's not even spelled that way. It's spelled like this.
I know, it's just pi, but still it should be a pi.
Okay, all right, let's get the question in. Okay, so if we punch it in, so we have pi times, and now since it's radius squared, that means we have to square the 8. Or if you want to phrase it as multiplying 8 times 8, you could do that too. 8 times 8 would give you how much?
8 times 8. 64.
Okay. So if they want it
so
if they want the answer in terms of pi, then it's 64 pi, and
I had to wear my favorite cat pants.
Stop.
To.
Chill. Okay. So if they want the answer in okay, here, get your calculator. So if they want the answer in terms of pi, then you got 64 pi, all fine and good, you're all set. Okay? If they want it.
Wait a second.
If they want it as if they want you to use 3.14 for pi, we'll get that. Or 64 times the real pi. If they want that, we'll get each of those answers. So calculator, get the calculator out. Okay. Could you stop that?
What?
No, you can't go with it like that. Okay, so let's punch it in. So let's see. 3.14 times the 64. Okay. If you're using 3.14, you get about 200.96. And now remember, this is an area calculation. Area is two-dimensional. So you can't just say 200.96 units. You have to phrase it in square units for this. Okay? Because the perfect version of a two-dimensional figure would be a square. Okay?
Like this.
For the artiste in all of you. Okay.
No, that's a rectangle.
Close enough. All right.
No.
If we use the real pi, we do that times the 64, and we get the slightly bigger answer of 201 times rounded off 0.06 square units. Okay.
Oh, good Lord! Look at that number.
Again, any of them would be Either of those would be acceptable. Any of these three would be acceptable depending on exactly how they want you to phrase the answer. Okay, but here's the bigger... Okay, chill. Okay.
Good Lord. There's...
That's why they want you to round it if they give it to you that way.
rectangle and there's baby square.
Okay, now that's fine if they... This is fine if they give you the radius. But what if they gave you a diameter like this one, though, Brianna? Okay, because in this one, Brianna, follow. In the area formula, you have to use a radius. You can't use a diameter. So if you're given like in this circle, if the diameter is 10 units, what does that make the radius? If the whole thing is 10, how much is it? Right. So the radius in this case would equal 5. So 5 then is what you would have to use in this. Pi times 5 squared. Okay. That would give you 5 times 5 would be 25. So you'd have 25 pi, or let's see, 25 times 3.14 would give you 78.5. Okay, or if you're using the real pi times 25, it gets about 78 points, rounded off 5.4. Okay, depending on what form it is, but again, all in square units, so you're good to go there. So the key here is that you're going to have to watch. You have to watch closely with regards to exactly whether they're giving you for both circumference and area. You have to watch whether they're giving you the radius straight up, which means it's from center to the edge, and that's the main number you need in both of those formulas, versus if they give you a diameter, which if they do, you have to interpret its use properly. I would personally recommend convert the diameter to a radius so that you can use either formula as you need to in whatever circumstance. Okay, so we got that, and we go on there. Okay,
that's
now
a Pokeball. Dad, you drew a Pokeball.
But you have... Wait a minute, but you got to understand. When a circle is drawn, you have to acknowledge where the center of the circle is.
Yes, but that makes
yes, I know. It looks like a Pokeball.
Pokemon!
It's not. Well, it's not. It's not quite, but never mind.
I want to be the very best.
Oh God! Don't butcher it, please. God, come on.
Okay. I want to be the very best, like no one ever was. To catch them is my real test. To trade them is my cause.
All right. Stop, please stop singing. You are really murdering the song.
I'm sorry. It's because I'm trying to do it while I'm trying not to laugh.
Yeah, and that's where it's messing up. I personally wish it. I personally wish you'd learn the Team Rocket theme with me.
Oh.
Come on, and you know we've done the song, we've heard the song before, you know how it goes. Okay, but again, another day, another time. So, all right, okay. One of your classmates, Gianna, has sent me.
Hi, I'm Sucko. I see you smiling.
Yeah. Now you're trying to get Mick Foley to tune in?
Wait, what?
I will teach you about Mr. Sacco later.
Wait,
okay, right, stop, chill.
Sacco.
Same thing. Anyway, okay. All right, so let me see what this question has to do with here, because we're staying in the area category, actually getting a little bit into the volume category a little bit. Okay, so let me see this question here. Okay, so okay, because I got two questions here I'm looking at. Okay, let's see which statement correct. Okay, I'm going to look at this one question down here about with regards to. All right, now I just want you to see the figure that is being sent me. I'm looking at the picture and the volume here. We talked about area. Let's get into a three-dimensional calculation and talk about volume. I don't know how well you could see this here in the camera, but okay. Do you see that? You see that image there where I'm going to recreate on the board in a second. It's taking a rectangular prism, a box, and it's putting a series of unit cubes in there.
Wait, this is one of our sheets?
To basically give you the dimensions of the cube in terms of its length, its width, and its height. Okay, so I'm going to recreate that picture in just a second. All right,
Wait,
can you chill?
so
All right, here,
wait,
do me a
that's
favor.
actually one of our problems?
It might be or whatever. Okay,
Oh,
do me a
no.
favor. Wait, hold on. Can you run down real quick? Ask mommy real fast whether. Or come on.
Okay.
Ask mommy real fast whether Gianna wants to know about number 4 or number 5. I'm going to do number 5 right now, but if she wants to know about 4, let me let me know so this way I can do that one too. Okay, just okay. Ask. Let mommy finds out. Okay, so all right, so let me recreate the picture here just so you can see it. So you can see it a bit more clearly as the comedy continues. The comedy continues over here and stuff like that. All right, so you got the rectangular prism. You got it like so. You got the box right there. Okay, and so the way this looks is that they've put a series of unit cubes along the dimensions here, so you know exactly what the length, the width, and the height of this are. Okay, so from what I'm seeing here, this is the way they're showing it here. They're showing that. Oh God, I'm gonna see how well I can do this here. Okay, so I'm seeing that the height of I'm seeing the height of everything is okay. So I'm just trying to see if I can recreate this and get this straight here. Okay, the height appears to be like this. It appears to be. Go ahead. It's a. It don't matter to me. Get whatever you want. I'll eat anything. Life on the fly here, folks. Anyway, okay, so I see it there. Okay, now I got it. I know it's tough to recreate this. I understand when you're trying to put this together on the fly. It's not the easiest thing in the world, but we'll get it. We'll get it all straight there. Anywho, so okay, here's what we
Dad, are you okay with calamari? Getting a calamari appetizer?
Shh, please, you know me better than that.
Okay, so I'll take that as a yes. I don't know if there's a matching sock for this.
Could you come on? Now you're getting too
Taco.
enough. Come on. She's missing the point. She's losing sight of why we're doing this, folks. Anyway, okay. So they're showing here that there's a height of in the box of 3 unit cubes. There's a width in the back of. Actually, no, I'm sorry. It's 5 unit cubes, not 4. Let me throw in an extra one. There, something like that, give or take or whatever. Okay, and then the length going forward is and the length going forward is 4 unit cubes, which it's somewhere in there, whatever the case is. So, okay, so it's something like that. Okay, so that's as good an accurate drawing as it can there. Okay, and they want to know what is the volume of this rectangular prism in cubic units. Okay, cubic units because it's a 3-dimensional figure, therefore a 3-dimensional calculation. And the perfect version of a 3-dimensional figure is a cube, going square dimensions all around. So knowing what you see here and counting the unit cubes like it shows that there are, like it says, going up the back, you count 1, 2, 3, and then here at the intersection of everything is a 4th one. So it's 4 unit cubes going this way.
Okay, I'll stop.
Okay, now going across the back for the length of the thing, there's 5 going across the 4 that you can see, and the 1 that's hidden by the intersection of this, and then the height. You see 2 cubes stacked, but again, plus the 1 hidden in between they're standing on, so that's 3.
What do you mean?
So
the one hidden. Oh, that one.
Well, yeah, there has to be a connection to all of these in
Okay.
between. They can't just float in space. That's the thing. So volume is just, so with all three of those dimensions, that's pretty much what it is. It's length times width times height. I know, use a lowercase, so I know.
Why?
So I know that it's a fussy thing. I don't get either. But either way, you've got all three of your dimensions right there. So, and being that it's all given to you straight up, it doesn't matter what order you put them in. So the fact that I put the 3 over here instead of over there like it was supposed to really doesn't make a difference. Okay, so length is 5, width is 4, height is 3. So we multiply all 3 of those together, and that tells me in cubic units what the volume of this prism is supposed to be. So real quick, 5 times 4.
20.
Times 3.
60.
60. Okay, so we get 60 cubic units, and that's all fine and good to go here. Okay, now was there a question about?
Can I erase it?
Huh?
Can I erase it?
Wait, don't erase it yet.
Oh no.
Okay, wait. So let me see. Oh, okay. I was looking at the other question here. I was trying to see, like, okay, what did they want to know there? I was gonna say, was this an area and a volume problem too, or apparently not? Okay. So, all right, the other question that's here on this particular page, okay, it's talking about place value and numbers and stuff like that. Okay, so here, there's 2 numbers that they're giving here. All right, so here, where'd the rag go? Where'd the root beer rag go?
Root beer.
Ding, ding, ding.
Oh, can I erase this?
That's a Billy Joel song, the root beer rag.
Can I?
No, leave that for a second. It's okay. I mean, we don't need it, but it's fine. Okay.
Okay, then I'll erase it.
All right, so
I'm erasing.
here's what they want to know. Here's the question that they want to know there. Okay, they're asking you to compare 2 numbers here. The one number in the problem is 26.495. The other number is 17.64. Okay, now the digit that they want you to focus on both of these questions, Brianna, is the 6. Okay. So that's what they're focusing there. Now, the thing is, in each one, the position of the 6 is in a different place value position. We'll start first by identifying what place value it's in. So, like in this number, yes, you look up in this number, the 6 represents what place value? What position is that in?
That person. One's place.
Okay, could you take the sock off, please, so you can actually write properly? Okay. And besides, I want to write this in its, no, I want to write it as the name of its term there. Okay, so this is the 1's position, okay? What does the 6 represent when it's over here, just to the right of the decimal point? Tenths, yeah. You must emphasize, enunciate, and get that th in there properly. Let's do it together. Yeah, really throw your tongue in it. Tenths. Make it sound like you have make it sound like
duck.
Make it sound like you have Daffy. Yeah. When's the last time you've even watched Looney Tunes that you even remember Daffy Duck?
Technically, I didn't watch it, but yesterday I was watching this video. Oh, guess the cartoon voice, and I think Daffy Duck we went up. 10.
Yes, and of course we have to remember that Daffy Duck was the originator of what became Sylvester's catchphrase because both were voiced by the legendary Mel Blanc, but Daffy Duck came long before Sylvester, and it was he who originally had the catchphrase "Thuffer and Thuckatash."
What?
Don't ask.
What does it actually say?
Huh?
What does it actually say?
That's what it is.
No, I mean without the list.
Suffer and succotash.
Huh?
Don't ask. I don't get where it came from either.
Well,
and
what?
WWE fans don't get why Roman Reigns was using it a few years ago either. It was a very poor attempt at giving him a catchphrase to get him over. Proof that WWE shouldn't be scripting their material. Let them come up with their own stuff. Anyway, getting back on point. Yes, exactly. Nobody gets it. Anyway, so okay, so ones and tenths. So now here's the question. But now, all right, coming back to this though. So we know the place value of those two numbers. So here's what we got to know though, Brianna. I want to know. So which one is technically, which 6 technically has a greater value? The one in the ones position. But now here's the next thing I want to know. How many times? Okay. All right. Well, okay. You could have just said that. Okay. No. But it is
10 times bigger.
It is 10 times bigger, and it comes back to what with digits and decimal positions and stuff like that. So you have to recognize that when you're counting, every time you get 10 of a specific place value, it could be converted to 1 of the next place value, and that given position starts at 0. So we want to recognize that ones is 10 times bigger than get this actually written properly. 1 times is 10 times bigger than 10. Okay, that's all fine. But here's what is it the other way around? If ones is 10 times bigger, okay, you don't say 10 times smaller. Okay, you have to try to what is it the other way? Because now here we know you're multiplying. Well, wait, hold on. No. Wait, that would be the same as saying 10 times smaller, but you kind of really don't say it that way. So wait, follow me on this. We know that if you're going bigger, we know you're doing a times 10. If you're going to a smaller number, instead of doing a times 10, you're doing what?
10.
No, wait.
Less.
No, that's what you said a minute ago.
I did?
No. Yes, that's exactly what you said.
10 times difference.
No. Wait. Listen again. Hold on. Don't your mouth run away from you. Okay, so hold on. Anyway, so here's the thing. Again, if we know you're going to end up with a bigger number, okay? If we know you're going to end up with a bigger number, then we know that you're multiplying. If you're going to end up with a smaller number, what operation are you doing instead? Instead of multiplying, all right, you're dividing. Okay, but here's the thing. I want to phrase the division as a multiplication. So the key is So the key is this: the division of 10 is equal to the multiplication of what? If you remember, we also when we did when we did division of fractions, remember we talked about the reciprocal, turning it over. What fraction would a whole 10 become when you turn it over?
1.
Exactly. That's what we want. Yes.
1/10 of. Oh my God.
It's 1/10 times the value of ones. Okay. So that's how you want to see it. Okay. So those are the statements that you're looking for there. So whichever choice in the question has that information, then we're set to go and stuff like that. So that's the kind of thing that we're going to see there, and so on and so forth. So just whichever one of these questions has that accurately depicted, that tenths is 1/10 times 1.
Clean up.
Okay. Yeah. And one would be 10 times 1/10. That's how that would go. Okay. So that's the nature of those two questions, and hopefully and hopefully Gianna, that helps you out in getting that question, in getting both of those two questions on that picture you sent us answered there and stuff like that. Okay. So that's the nature of things there. Okay. All right, I'll tell you what. Here, wait. I actually want to do different question. Okay, here. I promise you this. We'll get the all right, here. I'll see if we can get the I'll see if we can still get the Adopt Me Math back in and stuff like that. But here, I want to do
Wait,
one.
are you still gonna keep the old one up?
No, wait. We're gonna recreate in a second. Okay, I have one other question. While we're on the discussion of this multiplication and stuff like that. Okay, there is one other type of question I was about to discuss before everything started. Before I got the other suggestion, things started going haywire. Okay, you remember last week we briefly, when we were doing the interest discussion, we were talking about percentages, and we did multiplying the decimals and things like that. Correct?
Mm-hmm.
All right, so I want to just briefly have a discussion about both of those with regards to like percent of a number and things like that. Okay, and what you're going to see in a minute is that the things that we did about converting percents to decimals and doing decimal multiplication, those are going to be important to the conversation here. So just a couple of fast questions with regards to that. If I ask you, Brianna, okay, and again, what percentage represents everything? How much? One whole represents what percentage?
100.
100%. Okay. And like I said, you can obtain that, if you take the percentage value and you move the decimal over 2 places to the left, that's what creates the one whole, like you see it there. Okay, so that means that just to again see it, if you wanted, let's say 35%, 35% would translate to what decimal? Imagine if the decimal point is right there and move it over 2 places, what amount would it say? Okay, 0.35. If you had something like this, what if you had let's say 5.25%. That decimal point, you see it right there. Still move it over 2 places and see what decimal it creates. Let's see if she's got this nailed down. Oh, nice. That's it right there. No. You don't lean. No. Form. The form. We're still working on the Basham Brothers thing there. But okay, now you got the idea. That's how it works.
I'm like,
okay.
Wait, it's 2 places, so that means
right, exactly. So you have to create that. You have to create that extra 0 to occupy that extra spot there and stuff like that. Okay. So now you know those. Now, making those conversions is important because if you're trying to calculate the percent of a number, okay, and that's a very important thing. Percent of. Anytime you're seeing the of, that represents that you're going to be doing a multiplication. You have to turn the percentage into a decimal, like we did there, and then you're going to multiply it by whatever the follow-up amount is. So if I wanted you, for instance, to calculate 40% of, okay, if I wanted 40% of, let's say, 20, okay, so we want to recognize again that of represents times. We bring the 20 down. Okay, convert this to a decimal. Move it over 2 places, and what would it say? Okay, you could say 0.40, or because it ends in a 0, you can just call it 0.4, and that's completely okay too. Now we do no, it's fine. Now we do that now we multiply these. Now remember, imagine it first as if it's just 20 times 4. What would it just be if it was 20 times 4? It would be 80, but then wait. But then between the two, how many total decimal places are there? How many total decimal places do you see right now?
1.
1 place, which means, so write this as if it has 1 place right there. So the answer would be 8.0, or you can just call it 8 and leave it fine right there. That would be the end result there. Okay, what if? Okay, so. Okay, now you see you're getting a little advanced notice here, because again, I know some of my higher levels are going to do this kind of thing. Okay, so what if then? So all right, what if instead we wanted, let's try. Okay, try this one, Brianne. What about 75%? Okay, so same story. Convert. Okay, convert to a decimal. 0.75. Okay, times the 24. Okay, so we got a little bit of a hit here. Okay, just gonna clean that up a little bit. That's just because we're at. Okay, so you get 300 there. Okay, so all right, the ghost 0, 1. Okay, put it there. So without any decimals, you got 1,800. But again, between the two, there's how many total decimal places?
What?
No, read again. No, read again. How many total decimal places do you see? Read this number. It doesn't have one decimal place. It has two. So put 2 in, and you can drop the zeros, and you get 18 exactly. Okay, so that's it there. All right, very good, very good. So that's
That
so yeah, huh? So that's
just gonna create a silly question. There's probably not gonna be an answer to it. A real answer.
Wait, hold on. Don't do it now. Show me after we're done with the show.
Then can we
And
do
that
beginning?
well, if
Tomorrow.
if it's possible. No, not now.
But then they won't get to know.
No. Tell me later.
Dang.
Don't. No, because no, seriously.
Okay.
you know my friend Scott, he does the exact same thing. Don't pull that. Yeah. Don't pull that. Okay? Because I will be here another 2 hours. We don't have another 2 hours. Okay, so don't do that. Anyway,
you're probably gonna be like, no, it's not possible.
That's why I want to see it after the show. Okay, all right. Let's do the one that we know we can do. Okay. So this is just to the Adopt Me Math in Roblox guys. Okay, this is what okay, so I didn't erase it. Okay, so let's thing in the Roblox, which is $8,000. You said it was.
The apartment building.
Okay, so that's the nature of things. Okay, calm down. You're shaking the whole studio here. Okay, the earthquake was in Utah over the weekend, not here in Jersey. Anyway, okay, so stop.
I'm excited.
Okay, but no, that also messes things up over here. No, sometimes it does. No, you'd be surprised. Anyway, okay, so the whole thing was $8,000. Now, the other main fact that you mentioned was that that every 20 minutes or every 10 minutes of real life time, a full day passes in the game, and you collect $20. So it's $20 every 10 minutes. Let's reestablish that fact. Okay, and then as she was starting to tell me when we did this thing last time, she was saying how on every real life day when you log into the game, you're going to get like some monetary bonuses, and they cycle every 5 days and stuff like that. So the first day that you log in, you get an extra $25. On day 2, you get $50. On day 3, you get $100. On day 4, you get $200. And then
find someone that really wants what you got from the gift, and you can sell it.
but
that's probably not going to happen.
But again, we're just assuming in this problem that you are totally acting on your own and stuff like that. Yeah. Okay, so from all of this, from all this information, there was an algebraic problem that we were able to when we did version 1 of today's live stream, that we recreated based on all of this. And to be honest with you, as I was starting to say in take 1 of today's stream, the way all of this organizes actually is like for what we eventually did, it's kind of sort of on level with like what an Algebra 1 question would look like on the state testing here in New Jersey for Algebra 1, which
Dad, I just realized
some people may feel chill.
Technically today is day 12, but then I just cut some marks.
We'll figure it out later. Let's go on this assumption for right now. If the details are slightly different, we'll talk about it another time. But let's just assume that you only get the one thing every calendar day that you check in. Okay, so let's just go on that assumption. Anyway,
maybe I just like.
Don't worry about it. It's fine. Let's go with it. Let's go with this. Okay, so that's the nature of the game. So So let's suppose that you want to try to rack up this $8,000 in one month. Let's say you want to be able to accomplish it by the end of the calendar month. And we said before that typically when the 1 month is used as the thing, it's usually symbolized as how many days? We put it over here. 30 days. That's why I wrote that up here, so we can keep that on the side. Okay, so here's the state test question that could be devised out of all this pretty much or whatever. Okay, and who knows? Maybe if you're not in Jersey, maybe your state has something similar to it as well. If and when we ever get this. Okay, which means then. Okay, so how many of these 5-day cycles can we complete in a month? We said there were. Okay. 6 cycles in a month. Okay, which then we did that multiplication and then we proceed. So we did that here. Punch it back in real fast. 375 times 6. Punch that back in one more time just so we have that number back in front of us. Okay. 375 times 6, and we get KT. Okay. So
that's how much money you get from the login bonus?
From the login bonus per in 1 month's time. So we have that. Now, as far as the hours every 10 minutes goes, okay. If we say that M represents the number of, we said it would represent the number of 10-minute, of 10-minute intervals. Intervals means a continuously repeated passage of time or space or length or whatever it happens to be. Okay, so from that information, here's the two-step equation we were able to create. 2,250 plus, now here's the M, but again, for every one of these, you get $20. So since it's 20 for every single one, that means it's a multiplication. $20 times the number of 10-minute intervals there are. And all of that has to total $8,000 by the end of the month. So that's the two-step equation we ended up solving. So once again, we'll solve it again real fast. We said first you had to do what with the 2250? Subtract it because you have to get rid of it there. So gone. We did that, and we ended up getting 5,750 right there. And then we had to do what with the 20? No, wait, it's multiplying now. To get rid of it, you have to divide it. So we divide by 20. So here, hit the division again real fast so we could see what it came out to. Because I know 50 divided by 20 doesn't go evenly. Okay, it came out to 287.5, which we go back to interpreting decimals again. We said that for this one, since there was a decimal, regardless of what decimal came out, we had to do what with it automatically?
Round.
Which way? Up. We said no matter what, we had to round up on this because if you round down, especially if it's a low decimal, if you round down, you have to remember you only collect the $20 once 10 minutes passes. You intervals to pass. 2880 divided by 60. And it came out to to 48 hours, which as we were saying with when Mommy was up here, we were trying this the first time. So those of you Nick Nolte and Mel Gibson fans of the 80s, your satisfaction, your appreciation for 80s cop movies has now been satisfied. 48 hours right there. So so that's how much time you would have to spend logged into the game, continue in some continuous form. So that's
usually people just like log in once every day.
Yeah. So play it off of that, and you're all fine and good. That's it.
But that's okay.
Okay. Yes, and thankfully this time around for the second take of today's live stream, the internet connection this time stayed all right. We made it through this time. Huzzah! Yes.
Oh, I was about to.
Yes, no, remember. Okay, yes, got it right there. Perfect. So, and hopefully, as we keep on having to do this for the days and the weeks as this goes on and stuff like that. Okay. And again, I appreciate yeah, anybody watching this. Hopefully tomorrow at 2 p.m. we're gonna go live again. We'll do it
with
in
no problem.
yes, with no problems, no hiccups, or whatever the case is, and hopefully most of the time
With
we'll
actual
be able to keep doing that and stuff or whatever. So other things are coming. Subscribe to the channel here, and please tell your friends here. We got a little content here. We got a little viewer submission on this. However, I thank you, appreciate it. It helps keep the content here going because no, seriously, without you guys, we're nothing here. We're really fishing here. We want to help you guys, so keep on coming by.
That's the whole reason we're doing this. That's the whole reason
Yes.
that the channel.
When hopefully everything works straight from the get-go. I'm Brian Sapinski. She's Brianna, and on behalf of my son Joey and my wife Andrea downstairs, whoever who try to contribute in their own ways. We'll see you tomorrow. Take care, guys. Stay safe, stay healthy, and we'll see you. It's a little too close.
That's the bye.
Too close.
Bye.